So welcome students. So in this question, given that you have an ellipse which is centered at origin and has its major axis as x-axis, along x-axis, with SS dash, the distance between the focus, the distance between the foci being equal to 4, and SP plus S dash P is equal to 6. P is some point on this ellipse. And this is the given information, and it's given that this ellipse is inscribed in a triangle ABC. This ellipse is inscribed in a triangle ABC. If that is so, what is the locus of the vertex A if, in the first question, angle BAC is equal to 90 degrees. If this angle is equal to 90 degrees, what is the locus of A? If angle POQ is equal to 90 degrees, if this angle is equal to 90 degrees, what is the locus of A? And if the difference between the eccentric angles of P and Q is equal to 60 degrees, what is the locus of A? P and Q are the points where PQR are the points where the sides AB, AC and BC touch the ellipse. So if the triangle ABC is circumscribing this ellipse, the ellipse will touch the sides at some points. So those points are nothing but PQR. So let us try to solve this one by one. So if you take the question 1, so you are asked to find the locus of A if angle A is equal to 90 degrees. So if angle A is equal to 90 degrees, it's a very simple case. This is a case of the director circle. That means A is the point of intersection of perpendicular tangents to this ellipse. A is the point of intersection of the perpendicular tangents to this ellipse. Hence, the locus of A is nothing but the director circle of the ellipse. So, the director circle of the ellipse is given by x square plus y square is equal to a square plus b square. Now, from the given information, let us try to find a square and b square. So, first, SP plus S dash P, if P is a point on this ellipse. So, SP plus S dash P, if you sum the focal radiuses, so we know that the sum of focal radius is equal to the length of major axis. So, the length of major axis is equal to 6. The distance between the foci, which is 2AE, is equal to 4. This implies E is equal to 4 by 6, which is equal to 2 by 3. If you divide one with other, E is equal to 2 by 3. So, once you have E, you can find the value of B. So, we know that B square is equal to A square into 1 minus E square. That is equal to A square is 2A is equal to 6. So, A is equal to 3. So, A square is 9 into 1 minus 4 by 9. That is equal to 9 times 5 by 9 is equal to 5. So, B square is equal to 5. A square is equal to 9. So, what is the equation of the director circle? So, x square plus y square is equal to a square plus b square. 9 plus 5 is 14. So, that will be the corresponding locus of A if this angle is equal to 90 degrees. So, let us go to the second question. So, in the second question, you are asked to find the locus of A if angle POQ, if the chord PQ subtends an angle of 90 degrees at the center. This angle is equal to 90 degrees. So, now how do we solve this? So, this is a question on the topic of homogenization in pair of lines. We have a process called homogenization. So, how do we apply this? So, if A is the point h comma k, let us take h comma k as a locus point. So, now if A is h comma k, PQ is the chord of contact of A, and this chord of contact is subtending an angle of 90 degrees at the center. So, how do we ensure this 90 degrees? So, what we do is, let us try to find the equation of this pair of lines, OP and OQ. If I want to find the equation of this pair of lines, what I just need to do is, I need to homogenize the ellipse with this chord PQ. If I homogenize the ellipse with respect to the chord PQ, I get the equation of pair of lines and I'll equate the angle between those pair of lines to be 90 degrees. So first let us try to find the equation of the pair of lines. So for that I need to homogenize the equation of ellipse with the equation of the chord. So first, what is the equation of ellipse? X square by 9 plus y square by 5 is equal to 1. This is the equation of ellipse. And what is the equation of the line PQ? This is nothing but the chord of contact of PH comma K. So let us first write this in single line. So 5x square plus 9y square is equal to 45. That's the equation of ellipse. Now what is the equation of the chord of contact PQ? T is equal to 0, that is 5x square becomes hx. So 5hx plus 9ky is equal to 45. So PQ is 5hx plus 9ky is equal to 45. And this is the equation of ellipse. Now I just need to homogenize this ellipse with respect to this. So how do we homogenize this? So you have, so the equation of the pair of lines POQ is nothing but, so equation of POQ pair of lines is nothing but 5x square plus 9y square minus 45 times 5hx plus 9ky by 45 whole square is equal to 0. So now let us try to simplify this. So you have, so 145 will get cancelled out. So 5x square plus 9y square minus of 25h square x square plus 81 k square y square plus 45 into 2 90 hkxy divided by 45 is equal to 0. So 145 will get cancelled out, another 45 is left out. So the effective equation is 45 into 5 minus 25h square. 45 into 5 is 225. So 225 minus 25h square times x square plus 45 into 9, 40 into 9, 360 plus 45, 405. So 405 minus 81 k square times y square minus 90 hk xy is equal to 0. So this is the equation of the pair of lines POQ. Now according to the given question, I want the locus of h comma k such that the angle between these pair of lines is 90 degrees. So when will the pair of lines be equal to? When will the pair of lines be perpendicular to each other? If the coefficient of x square plus coefficient of y square is equal to 0. That is the condition for perpendicularity of pair of lines. So this implies the condition is 225 minus 2h square minus 25h square plus 405 minus 81k square is equal to 0. So now you got the equation in h and k. So to get the locus, I just need to substitute x in the place of h and y in the place of k. So 25x square plus 81y square is equal to 630. So this will be the equation, this will be the required locus. So if I have to, can I cancel anything? So 5 will not cancel here, 9 will not cancel here. So this will be the equation of the locus for second question. So now in the third question, you are asked to find the locus of A if the difference between the parametric angles of P and Q is equal to 60 degrees. So how do we do this? So the logic is simple here again. So the chord of contact of A should meet the ellipse at 2 points whose eccentric angles differ by 60 degrees. So let the angles, eccentric angles be theta and phi. So now if A, h comma k is a point on the locus, what is the chord of contact of A? So equation of PQ with respect to A. If you look at it from this side, so PQ is the chord of contact of A. So what is the equation of PQ? So we know that the equation of ellipse is 5x square plus 9y square is equal to 45. We have already done this. So what is the equation of PQ? T is equal to 0. That is 5hx plus 9ky is equal to 45. Now if I assume the eccentric angles of P as theta and Q as phi, equation of PQ, if I write it from another viewpoint of theta and phi, it will be x by a. So if the equation is x square by a square plus y square by b square is equal to 1, if this is the ellipse. If this is the ellipse. Now the equation of a chord joining P theta and Q phi is x by a cos of theta plus phi by 2 plus y by b sin of theta plus phi by 2 is equal to cos of theta minus phi by 2. So that's the equation of a chord joining P theta and Q phi. So let us write the same thing. So the equation is x by a is a square is 9. So x by 3 cos of theta plus phi by 2 plus y by b square is 5. So y by root 5 sin of theta plus phi by 2 is equal to cos of theta minus phi by 2. Theta minus phi is given as 60 degrees. So cos 60 by 2 is cos 30 degrees, which is root 3 by 2. So equation of PQ from the standpoint of A is this. From the standpoint of ellipse has to be equal to this. So both of them have to be same. Hence let us equate these two equations. So if these two equations are same, then the ratio of the corresponding coefficients have to be same. So you have cos theta plus phi by 2 by 3 times 5h is equal to cos, x coefficient is cos theta plus phi by 2 by 3 by 5h is equal to sin of theta plus phi by 2 by root 5 times 9k is equal to root 3 by 2 by 45. This implies cos theta plus phi by 2. So cos of theta plus phi by 2 is equal to, if I multiply this here, so this 3 and so 15h into root 3 by 2 into 45. 15h into root 3 by 2 into 45. So 15 3s are. So this gets root 3, that is equal to h by 2 root 3. And sine of theta plus phi by 2 is equal to, if I again cross multiply this, so 9 root 5k, 9 root 5k into root 3 by 2 times 45. So 9 5s are, root 5 gets cancelled root 5 times. So sine theta plus phi by 2 is k root 3 by 2 root 5. So if you eliminate theta and phi, cos square theta plus phi by 2 plus sine square theta plus phi by 2 is equal to 1. Hence h square by 12 plus, if you square this, 3k square by 4 into 5 is 20 is equal to 1. So this is the condition on h and k. Once you have a condition on h and k, you just need to replace h with x and k with y for locus. So x square by 12 plus 3y square by 20 is equal to 1. This is the equation of the locus. So if you want to cross multiply this, you can do this. So 20x square plus 36y square is equal to 20 into 12 is 240. So this will be the equation of locus. So if you want to divide it with 2, you can do it, or you can also divide with 4. So 5x square plus 9y square is equal to 60. So this will be the required locus. Thank you.